Okay, so in lesson 4, we're going to talk about geometric sequences in series. And a geometric sequence is basically just an exponential model. So if we double things, triple them, cut them in half each time, all right? That's what a geometric sequence is going to be. So where arithmetic was linear, so we add 3, add 4, subtract 2, subtract 2, 4, whatever. Where geometric is exponential, and we're going to have what's called then, we had the common difference with the arithmetic. With geometric, we have what's called a common ratio, R. So here we have an example from Wimbledon in 2003 that they started out with 128 tennis players. And what happens every time there's a match that's played? Somebody wins, somebody loses, right? So what does that do to the number of players that are still playing? Cuts in half. So our value for R, our common ratio then, is going to be 1/2 because every time we cut the amount in half that we had from before. So we have 128, then 64, then 32, then 16, and so on. And so we could figure out, okay, then how many matches did it take to get to the winner? Or how many rounds, we could say how many rounds to get to the winner. And then we could figure out also how many matches were played. So that would be the sum of them. And so we're going to talk about that. We'll talk about the sum or finding the series tomorrow, but we're going to do the specifics for geometric sequences right now. So the first thing we did with arithmetic, we said, okay, how do I know if it's arithmetic or not? Okay, right? If the first difference is the same, right? So how can I tell if something's geometric? Nope. Second difference is quadratic. The ratio. Okay, that's why the common ratio. So if the ratios are the same, then they're geometric. So since we've already talked about the arithmetic, we're actually going to look for both. Determine whether each sequence could be geometric or arithmetic. If possible, find the common ratio or difference. Right? So some of these you should just be able to look at them and say, oh, yeah, I know what that one is. Okay. So let's look at letter A. 100, 93, 86, 79. Okay. What happens from one to the next? Okay. They're subtracting 7, right? Okay. So since this one is, they're subtracting 7, that means it's what? Arithmetic. And then the common difference would be -7. Okay. All right, so we can look at the differences, look at the ratios, but this is arithmetic. It has a common difference of -7. Okay. All right. Like most of them, you should just be able to see them and be able to determine what they are. Okay. Letter B. 180, 90, 60, and 15. Okay. Now, do these have a common difference? From 180 to 90 is 90. From 90 to 60 is 30. Okay, that's not linear. All right, so that's not arithmetic. All right, let's see. 90 divided by 180 is what? 90 is half of 180, right? Is 60 half of 90? No. Okay, so that's not arithmetic or geometric. So I would say that this one is neither. Okay. All right, that's neither. 90 minus 180 is not equal to 60 minus 90. Okay, for our first difference. And 90 over 180 is not equal to 60 over 90. Okay? A little subtraction, a little dividing. All right. How about letter C? Well, let's see. From 5 to 1 is 4, right? From 1 to 0.2 is not 4, is it? No. Okay, so this is definitely not arithmetic. So let's try geometric. Let's see. 1 over 5, does that equal 0.2 over 1 is that equal to 0.04 over 0.2? Okay. All right. Well, 1/5 is 0.2. 0.2 over 1 is 0.2. Okay. All right. And then obviously 0.04 over 0.2 is 0.2 also. So these are all equal to 0.2 or 1/5. And so that's the value of R. And this would be geometric. Okay. All right. I think what we'll do is I might save the check it outs for tomorrow. We'll just go through the examples today, and I might have you do some of the check it outs tomorrow. All right. Wouldn't that be nice of me? Okay. All right. So 6 minutes. All right. Now, so let's look at the equations then. All right. The equations, here's the rule for if we have using the recursive formula, okay, a sub n equals a sub n minus 1 times r. So to get from one term to the next term, we multiply by r. Okay, that's all that says for the recursive. To get to the next term, I multiply by r. Well, the general rule we're going to be using then for geometric sequences is this. A sub n equals a sub 1 times r raised to the power of n minus 1. It's exponential. If you remember when we did exponential functions, our equation was y equals a times b raised to the power of x. Okay? All right? Where a was our initial value and b was our common ratio, or how much it increased by or decreased by what rate each time. So this is exactly like our exponential equations we used to use. So a sub 1 is still our first term, and r is our common ratio. So here they want us to find the 7th term of this geometric sequence. So always to find the term, we need to know the initial value, common ratio, and n, just like we were working with the arithmetic ones. So, step 1, it says find the common ratio. Well, what's r in this case? Ben, what does it take to get from 3 to 12? Okay, what about multiplication? Okay, multiply by 4. And 12 times 4 is 48? Yes, okay. All right, so if I did 12 divided by 3, I get 4. Okay? Since I know it's geometric, okay, all I need to do is take any pair of these and divide them. Well, you should just take the easiest pair. Okay? 12 divided by 3, that's 4. There's my common ratio. So if I write the rule then, okay, first it says then write the rule. All right, so the rule is a sub 7 equals my first term, which is 3, times 4 raised to the power of n minus 1. That would be my rule. Excuse me. This is n. Okay. There's my rule. A sub n equals 3 times 4 raised to the power of n minus 1. Okay. A sub 1 is 3, my first term. My common ratio is 4. So then to find the 7th term, I just replace n with 7. And the nice thing about if you have the TI-84 with the update, it's really easy to put 7. You could put 7 minus 1 in. I don't know why you would, but and no, I can't do 4 to the 6th power. I should be able to. Wait a minute, that's 64 squared, which is, no, I don't know that. What is it? And that times 3 is? 12,288. Need another. There we go. Okay. So the seventh term for this sequence is 12,288. So they're going to grow a lot faster. Okay, because we're talking about exponential. Yep. Hence. Okay. So this rule is very similar to the arithmetic. Just a minute, plugging in those right numbers you need to use to get there. Okay. All right. Then one of the other things we did was looked at how can I find any term then? So here we're looking to find the eighth term of a geometric sequence. Now, still we can think of this as points like we did yesterday with arithmetic, but it's not exactly the same. So we have to think of it this way. We know that to get, well, let's do it this way. Let's go plug things in. So we have a to the fifth, right? That's our largest term. And a to the third would be my first term in this case. And r raised to the power of 5 minus 3. Okay, so think about what we did, right? This is just like it's just like this, okay? These two things are similar. It's just that this is the nth term, this is the first term, okay? Nth term and first term, all right? Well, could I put a different number there than 1? Yeah, okay? Doesn't matter what number you put there, as long as these two numbers match, okay? So, we've got a to the fifth is 324. A cubed is 36. And we don't know r, but it's r squared then. All right, so we divide by 36. And so we get r squared equals 9. Okay. Now, here's where it gets a little tricky. If r squared equals 9, what does r equal? Plus or minus 3. Remember, when you're solving an equation and you take the square root, you get plus or minus. So we could have a couple different answers, okay, when we find the eighth term. So now to find the eighth term, we're going to ignore some of the stuff. Let me see. So now to find the eighth term, we'll say we want a sub 8 equals, we'll work with the fifth term, a sub 5 times r to the 8 minus 5 power. Okay, so I can put any numbers here as long as I have those same numbers in the exponent. So a sub 8, don't know what that one is, trying to find it. A sub 5 is 324. And then I have r cubed. Okay, now let's think about it. Okay, if I cube 3, what do I get? 27. If I cube negative 3, what do I get? I get negative 27, right? Okay, since it's to the third power. So I'm going to end up with two answers because 3 to the third power and negative 3 to the third power are different numbers. So I'm going to end up with a positive and a negative answer in this case. So I have to do 324 times 3 to the third, and I have to do 324 times negative 3 to the third. So we're going to end up with two possible answers for a sub 8. Now, if this exponent I had here, if this exponent is even, it doesn't matter. I'm going to get the same answer, okay? because when I raise a negative to an even power, it's a positive. So my answer is then a sub 8 equals, what's 324 times 27? So plus or minus 8,748. So you just have to remember to do plus or minus whenever the power here is even. Whenever that power is even, you have to do plus or minus. Okay? All right, and I'm actually going to do the fourth example because this is really easy. Okay? Okay. We're going to find what's called a geometric mean. Okay? Are terms between any two non-consecutive terms of a geometric sequence. Okay? Geometric mean, basically, it's this. Okay? I have two numbers, and I'm trying to find the one between them. Okay? I have two numbers, I'm trying to find the one between them. So I have, in this case, we've got 4/9, some other number, and 25 over 36. And I want to find the number between them. And all I do is the square root of 4/9 times 25 over 36. Okay? Easiest thing you could do. Geometric mean. Take the square root of the two numbers multiplied together. Okay. All right, so let's see. This is really, square root of 4 is? Square root of 25 is? Okay, so in the numerator I have 10. Square root of 9, square root of 36, and 3 times 6 is 18. And so that's 5/9. Okay, wow. All right. Can't be much easier than that, can it? Okay, all right.